So my name is David Gerson, and today I'm going to be presenting a quick workflow that I developed to kind of help me understand kind of media brand positioning. Specifically, the goal of this analysis is to create a perceptual map. And kind of what is a perceptual map? A perceptual map is one of these really classic matrices that are always developed by consultants and other sorts of people to take a lot of complex information, condense it literally into 4 boxes, maybe less, and then display that to people so they understand exactly what's going on either in their industry or simply just going on with their own product mix. So the example that I'm showing here is very similar to what we'll be working on. And what it has is it's just showing, you have your dogs, cash cows, rising stars, and potentials. And what these are is they're different, different product types and the performance of them and the potential future growth. And so that's the 2 axes that are available. So the x-axis is the revenue that's being produced by these different products, and the success/growth is the potential they have to keep growing. Another famous example of this is the Gartner's Magic Quadrant, which is used frequently for almost everything in IT. And if you're at, the IT conference, there's a chance you've probably seen one before. The issue is there's a small problem with how these are developed. The biggest problems are that, for the most part, it's very qualitative. And when they're not qualitative, typically that means somebody has a scorecard and they're going through and they're checking off each box on this scorecard, and that's helping them to determine really where somebody is on the x-axis and where they are on the y-axis, and then they're simply plotting them. But they're still using a qualitative measure to determine what's going into that scorecard. And for the most part, it's not even happening with that level of degree. It's simply somebody looking at a chart, defining what their measures are going to be, and then plotting them as they see fit and trying to do this themselves. And as data scientists and very quantitative people, that's not the best approach, and it doesn't make the most sense. Perceptual mapping is a way that this is done specifically in marketing. So that what you can do is you can assess where your products are at and see what they're doing. Additional features that you can add to it are kind of adding in the different, not only products, but your product features. So what this is a perceptual map of the soft drink industry. And it's showing that not only do you have lemonade, Coke, Fanta, etc., but then you can also add in the different components that make a soft drink, or make another product popular. And then from here, you can determine where there's room to move in the market. If, let's say, you think that there needs to be a popular drink that's natural and high in taste, but let's say maybe you wanted to remove the sugar, and then you would position your product away from sugar, but still try to keep other features that are very similar to products in that quadrant. And this is just another example of how this can be used effectively, in this case with cereal. So we see that we really don't have anything that has good taste and high nutrition. Instead, we have a lot of things that taste just okay or are covered in sugar. And that's the state of cereal. And what we would want to do is we would look at this and say, oh, there obviously needs to be something in that corner. So for this process I developed, I initially designed a workflow like this at PyData Dallas, where I started learning Python, getting involved in the community, and figuring out exactly how Python can help me. Typically, the work I do is in R. So I don't know much about Python, but a lot of those same skills apply universally, as long as I know the different components that I need to perform an analysis. The advantage of Python, though, is that when I'm using Python, I'm able to not only use the different data analysis and data manipulation techniques, but also if I need to integrate with a web service, aka the Twitter web service, I have a very easy way to do that. Starting with my Twitter integration, it was incredibly easy, at least to start with. Twitter recently changed their API while I was in the middle of this project, and that threw a wrench in the gears, to say the least. But you can still go through and use the Twitter streaming application to monitor a few key either hashtags or keywords that you would like to be looking for. The tool that I used was Twython. And what made that great is, as you could see in this line right here, all of I'm not sure, can you see my screen there? Right here, at the very bottom, that's the one line that actually starts my streaming API. That's all I need. Everything else is just me telling it, what are you going to be streaming? And then I'm also telling it, here's my authentication tokens for the web service. So the data I pulled, I basically set up this web service, and I kept it running on an additional computer I had set up in my home for about a week. So I had a week's full of tweets based on what was in Twitter for the different companies that you can see. So Burger King, McDonald's, Pizza Hut, Taco Bell, Chipotle, Qdoba, etc. Now, there were some limitations with this, though. As I said, while I was in the process of doing this, the Firehose API was shut down. And also, when I was using the Twython package, I noticed that I wasn't able to filter on language. So the initial goal of this was I was going to have two pieces of data. The first was going to be the information I have about the different brands I'm looking at. So my McDonald's, Pizza Hut, different food companies that I would be analyzing and creating a perceptual map for. The other part of this is I would need to figure out which terms were important when I'm looking at these types of companies that don't necessarily apply to the entire span of Twitter. Just because if you've ever been on Twitter, people don't talk like they normally do on Twitter. People are very crazy on Twitter. And what makes that challenging is when you're trying to just find normal words and see how they apply in a regular context, that doesn't necessarily work within, the context of a tweet. So what I did is I had to find an additional data set that wasn't necessarily on Twitter, and it all had to be in English. Fortunately, however, SwiftKey, which is currently using their data for, I think they do some sort of automatic keyboard that's available for Android, they provide a data set where they have a bunch of different tweets that people have been using in the US so that you can try to predict what people will be using when they're using the SwiftKey keyboard. So I used that rather than Firehose data because it was more readily available and the Firehose API was shut down. The next step was tokenization. It's actually incredibly simple because if you're loading your data in as a string, you just press, dot split, and then I do the, dot split for a new line, and then I create a new function that's just going to simply do a lambda, and then for each line, I'm also going to split by string, and that's tokenization. There's tokenization available in a variety of other packages, but that was the way I did it in this case. Also, while I was doing tokenization, I decided to filter based on words or tokens that I knew I wouldn't be bringing forward. So this would be things like very small words that would appear too commonly, and just a lot of stop words that are very well known. So I didn't need to use processing power later on down the road to get rid of them. Also, I deduped my data because I noticed there was a lot of spammers who would continually say the exact same thing to the companies I was trying to monitor. And it didn't make sense to have their voices heard a lot, especially if they were bots, just kind of repeating the same thing over and over again. The next step in the analysis was stemming. So stemming is extremely cool because when you have a word that you're analyzing, you have both the root and then you have kind of whatever's left. So if I'm saying, I moved here, that's basically me just saying move, and then I have an additional suffix on that. But really, I'm looking for the word move because that's the most important. And if I'm looking at kind of the general view of a company, taste and tasted are very similar. So the algorithm I used specifically was something called the Porter algorithm. I think you can bring it in as part of nltk, but in this case, I was just using, I think it was the Porter package. Because once I had that available, I simply just told it, stem all of these words, and it would do that. The newer version of the algorithm is Porter 2, and in the context of this analysis, it worked really well. It did take a while, but I think it was worth it because all of my words, could be tied together, regardless of, whether they were being used as a verb or an adjective or a noun. As far as the algorithm goes, I'm not going to dive into it, but I did find a very good document, which is posted at the bottom. It's just a lecture on the different steps this algorithm goes through when it's trying to stem a word. From that list of stemmed fast food restaurants and the stem fire hose data, I brought that into a TFIDF analysis. The reason I did this is because I wanted to see which terms in that food data set were more important than the terms in the fire hose data set. And once again, that was incredibly easy, and I'll show you just how many lines of code that took using the sci-kit learn package. The reason that you needed to do this is basically it just gives you a score saying how important a word is. So right here, what I did is I just created a simple function that's able to take in the raw string document, and then using the TFIDF function from sci-kit learn, you can also include a tokenizer. So in this case, my tokenizer is just saying split on word, and it's going to tokenize it again. But that's just the way the API works, is that I wouldn't feed in my tokenized data again. However, since I had already stemmed the data and saved it off, that really didn't matter much. And then I also decided I would use the English stop words so it would know to avoid any stop words that are in the TFIDF vectorizer package, but not in the initial stop words I used, which was through nltk. Once I did that, I would then fit a transform, which would tell me how important the words are within my base document, so that's the fire hose data. And then I would return a transform of the values to tell me how important my words are from that compare docs data, which is the actual fast food information that I was looking at. After that, I just basically did a word count. The word count I used took a standard dictionary, and then it would plot it so I had a dictionary object that would hold the word count dictionary for each of these different fast food terms. Nothing really complicated there. The only part that was even a little bit tricky was just an intersection of where my fast food terms would show up, and then making sure that I would also add that word count and increment them for each of those different restaurants. Once again, that's not super complicated. Here we go. Finally, we actually dive into the part where I create the perceptual map. So the perceptual map is basically just kind of a dissimilarity matrix that's then used to provide context when you're replotting your data onto a graph. So there are two main types of dissimilarity matrices used. The first one is for your non-metric MDS. So the non-metric MDS is similar to PCA in that you're looking for continuous variables. When you're using the metric MDS and you're trying to plot it for the continuous variables, it's not easy to perform anything like a rank function, and for some other types of data, it's not always the best solution. The answer when you have something like a rank or a comparison is the non-metric MDS, which is instead going to plot how a single term or a single value compares to another value for an element. If you want to think about this most easily, you're going to want to be looking at unidimensional data. So in this case, we actually have the unidimensional terms for club hearts, spades, and diamonds. And this is seeing how easily people can visualize this information and kind of maintain the terms that they've seen based on the different, I think, the suit of the card. And so what you're then doing is you're seeing how easily these can be recognized versus how easily other suits can be recognized. And then what you do is you compare the differences between them by creating a dissimilarity matrix. Once that's done, you then, in this case, what they did is they performed a certain type of optimization that required the values to be above 1. So they multiplied their data by 1,000. And then they reordered the data so that everything was in the proper order. After that, they simply just took the sum of the left and the sum of the right side, and using that, they were able to order them on a single axis. And what we're doing is essentially this, but on a multiple axis chart. So once we actually get out of that, there were a few different ways that you could run MDS. So the first attempt I did was using sci-kit learn. And this is what we got out of it. The only problem is it doesn't maintain a lot of the information we need to provide any context. So obviously we can see things that look like they kind of make sense. Qdoba and McDonald's are very close because they're both great restaurants with high brand support. Burger King and Wendy's are close. Chipotle and Pizza Hut are kind of close. But we really don't know why anything is in the place it's in. Because I couldn't really get that to work, I decided to go back to R. Because I'm very familiar with the plotting libraries in R, and I know that they provide the exact information that I need for this analysis. So in this case, we're performing a standard metric MDS solution to find out where these different brands are positioned. And what we see here is that all of these different brands are plotted. Unfortunately, though, if you see where the words are that actually tell you which brand is located in a certain location, unfortunately, it's not right next to the dot that indicates it. So if you're looking at Qdoba or Pizza Hut, it might be that that little blue dot at the very bottom, but there's no way to be sure unless you go back in, pull out the raw data, and try to map that yourself. So I decided this wasn't necessarily the best fit, just because it's almost impossible to see what's going on here. The other solution was a non-metric solution, which I actually think worked out very well. So what this is plotting is, rather than trying to plot a dot and then a text indicator for what that dot means next to it, you're just plotting the text item itself and then the different words for the terms that it's most closely related to. And I'm going to go into a little bit later what sort of insights we can derive from this chart specifically, but it's very clear that we can see what's going on, and there's a lot of good information here once we start diving into it. Then the other solution is, like I said, MDS is similar to a PCA analysis. So what you can do is you can simply just create a PCA biplot, and that's going to plot your data a little differently, specifically using the continuous elements of your data to show the strength of certain relationships or certain features, and map a plot. While this is useful, one of the main drawbacks of this specific type of analysis is the goal isn't to provide us with a concise view of the data. So what we end up having is we have a chart that shows everything plotted on two axes, but it's not giving us necessarily the dissimilarity between everything. And unfortunately, because it's mostly trying to do a factor analysis of the data, it's not letting you have more data elements than factors. So since we're only looking at 8 different companies, we are limited to only 7 factors to analyze them. And we lose a lot of the information that we would need by having so many terms from Twitter. So after going through all those different packages, the one that was easiest to analyze was the non-metric MDS solution. From this, what we can see is that both Wendy's and Burger King have favorable offerings of both chicken and bacon. Taco Bell doesn't have any noticeable salad offering, but also McDonald's doesn't either, which is surprising because they've been, hyping up their salads for a long time. Also, price is frequently referenced when people are talking about Chipotle, Pizza Hut, and McDonald's. So they might want to look into diving into those tweets and seeing, is it because the price is too high, or are people talking about price a lot because the price is too low? Also, Taco Bell owns the term crunch. If you look at crunch, it's very far in the bottom and similar to where Taco Bell is located. What this would indicate is that really nobody else has a crunchy offering, and Taco Bell kind of exclusively owns that term. So what we would do next is, first we would try to find the profitability of these different firms and plot that similar to how the PCA was plotted on that previous chart to show us really which of these terms are the most profitable. Then, rather than looking at the firms and seeing how far they are away from that one profitable line, we would actually be looking at the data elements we're pulling from Twitter to see what types of offerings could provide us the most profit. So in this case, like I was saying with Crunch, if we found that Taco Bell was doing incredibly well, had high profit margins, and was generating a lot of revenue, people might want to be interested in looking into a crunchy option for themselves. Finally, as far as pain points learned goes, ASCII and Unicode conversions are always a huge pain. So I had to go through all of my different modules and basically make sure that they knew I was looking for Unicode data rather than certain types of ASCII. Every once in a while I would forget, but after I ran into this issue a few times, I just became very over-aggressive with making sure everything was Unicode, and even if it didn't look like it had maybe accidentally been cast to ASCII, I would still reconvert it myself, just to make sure that I never ran into that problem later. Also, since I was developing this solution iteratively, and I'm just running it on a laptop, and there's a lot of data on Twitter, whenever I would run a certain computationally just difficult step, I would then save it off using Pickle so I could pick it right back up immediately, rather than text. And that way I just needed to read in the file and I already have my data object back the exact way I was using it initially. While I initially did this project as a way to test R against Python, while playing with the plotting library, I realized it's really not worth the effort to fiddle with something, to do a function that already works well in another language. So the output of this was simply an 8 by 369 term matrix, which is more than enough for any programming language. When I have data of that scope, the limitations of R when it comes to parallel processing or processing out of memory, they really don't appear. Also, since I know I'm only going to be doing plotting, it made a lot of sense to just do the plotting within R. Finally, I'm sure everybody else knows this if they've been using Python for a while, sci-kit learn has almost everything you need. They have a LDA analysis, which is what I'm going to recommend I would do next to reduce my dimensionality even further. And also, everything in that package runs extremely quickly, and I don't have any of the problems I have using some of the more open source packages that are available in the community. A lot of times I had a great idea and I'd find a package that would perfectly do it, but the second I would install it, something would break, there were a lot of weird concerns, or it was almost too hard to implement. And I had none of those problems using sci-kit learn. Finally, what I would start doing next is I'd look into a latent Dirichlet analysis. What that would do is it would then topic model my tweets for me. So rather than looking at individual words, I would see the context and the topics that people are tweeting about, and then use that as my features for the MDS analysis. And hopefully that would allow me to use either PCA directly or another metric MDS solution. All right, are there any questions? Oh. I didn't. So I was just looking at the words themselves rather than the context of them. So I guess a good example is it was much easier to look at chicken than to look for people saying they were happy. And if you look closely at McDonald's, they have the two terms that are most closely associated with each other are love and hate, and they're both right next to McDonald's. So either people just feel strongly about McDonald's one way or another, but there's no determination as to which one is which. Well, if there are no other questions, I'll close out. Thank you for your time today.